Let's talk about a fundamental shift happening in AI right now. We're moving past AI that just gets language and pictures. We're talking about an AI that actually understands the laws of physics. And trust me, this isn't some small incremental step. This is a giant leap that could completely change how we do everything, from manufacturing to producing energy.
All right, so let me ask you something. AI today can write amazing poetry, it can churn out complex code, it can create unbelievable art. But what's the one single thing that these incredibly powerful models are totally blind to?
The answer? The physical world itself. Gravity, friction, the fact that a steel beam can only take so much stress before it breaks. Most AI has zero, what you might call physical common sense. And that's not just a tiny little flaw. It's a massive wall that stops us from using AI in the real world for things like our factories or power grids.
And this really highlights a huge gap in industry. See, on one hand, you've got the old school automation. It's super reliable, but it's also rigid. It does one job and one job only. On the other hand, you've got modern AI, which is incredibly flexible, but it's clueless about physics. You just can't hand the keys to a billion-dollar mining operation to an AI that doesn't understand the difference between a solid rock and thin air.
So how do we fix this? Well, this is where a brand new concept comes into play, one designed to perfectly bridge that gap. It's called the Physics Agentic Model. We can just call it PAM for short. And the whole goal here is basically to give AI a degree in physics. Now, the key thing to get is that PAM isn't just another AI model. It's a control architecture. Think of it as the bridge that connects the AI's digital brain to a physical machine in the real world. It makes sure every single decision, every action is grounded in the laws of physics.
So, that's the big idea. Sounds pretty cool, right? But how does it actually work? Let's pull back the curtain and break down the magic piece by piece.
Okay, so it all starts with something called a digital twin. I want you to imagine a perfect one-to-one virtual copy of a real factory, or maybe a whole wind farm. This isn't just a pretty picture. It's a simulation that is accurate right down to the laws of physics. This is the AI sandbox. It's a flight simulator where it can practice millions of times, crash and burn, and learn without ever breaking a single real-world part.
So by training inside this super realistic virtual world, the AI is forced to learn through what's called physics-grounded reasoning. It literally can't suggest doing something that breaks the laws of physics. The simulation acts like a strict teacher, enforcing all the rules, like torque limits on a robot arm or safety temperatures on a turbine. It forces the AI to play by the rules of our world.
But PAM's intelligence doesn't just stop at one machine. No way. It's designed for what we call swarm intelligence. So think of it as the central nervous system for an entire fleet of autonomous trucks or a whole factory floor full of robots. It lets them all talk to each other and work together like a single unified team. The scale here is just enormous.
So, if we put it all together, the process is actually pretty simple. Step 1, you build that super accurate digital twin. Step 2, you run millions, even billions of scenarios inside it. Step 3, you make sure every single AI decision respects the laws of physics. And then, and only then, do you move to step 4, you let it execute those optimized commands in the real world.
Okay, so that's the theory. But what does this actually look like when you let it loose in the real world? Let's take a look at the industrial superpowers PAM unlocks in some of the biggest industries on the planet.
First up, let's talk about smart manufacturing. You can pretty much forget the old, rigid assembly line. We are now talking about something way more intelligent, the dynamic assembly line.
With PAM, a factory can reconfigure its robotic arms on the fly. It can predict when a tool is getting worn down and adjust how it cuts to avoid wasting materials and improve precision. This means way less downtime. We're talking about a leap in efficiency that could completely rewrite the economics of a market worth trillions of dollars.
Next, let's jump over to the energy sector. This is a world defined by absolutely massive physical infrastructure and demand for power that is constantly changing. In the energy world, PAM acts like a hyper-intelligent grid manager. It can use incredibly local weather data to dynamically adjust the angle of a wind turbine's blades, squeezing every last bit of energy out of the wind. It can perfectly balance the supply of energy with demand, which, as you can imagine, is absolutely crucial for making renewable energy sources way more reliable.
And finally, let's go to one of the most rugged and challenging environments out there, mining and extraction.
Deep inside a mine, PAM can become the commander of an entire fleet of autonomous trucks, drills, and excavators. It makes sure none of them ever collide, it optimizes their routes to save huge amounts of fuel, and it can even adjust drilling pressure based on what the sensors are telling it about the rock. This makes these incredibly dangerous jobs so much safer and boosts productivity like you wouldn't believe.
So let's just zoom out for a second and really look at the big picture. What we're talking about here isn't just a smarter robot. This is a whole new architecture, a new blueprint for the next industrial era.
And the architecture itself is brilliant because it's designed for both intelligence and safety. Think of it like a person. The cloud layer is the strategic brain. It does the deep thinking, the heavy-duty simulations, and the long-term planning. But the edge layer, the part that's right there on the machine, that's the reflex system. It executes the plan, but crucially, it can react instantly to danger with zero delay. It is the perfect fusion of deep thought and immediate action.
And that really brings us to the core idea of this whole thing. The real breakthrough here is that we're moving from just operating machines to actually understanding them. By grounding AI in the laws of physics, PAM doesn't just tell a machine what to do, it understands why it's doing it. It understands the consequences. And that leaves us with one final, pretty profound question. For more than a century, we've built machines that simply operate in our world. But now, for the first time, we can build machines that truly understand it. So, what will they build next?